This is problem number 15 on sample final part 2. In this example, we'll find all complex square roots of -1 plus the square root of 3i. In other words, find all complex solutions of x squared equal to opposite of 1 plus root 3i. The first thing we want to do is rewrite -1 plus root 3i in the complex plane. So we'll go ahead and introduce our coordinate system. So we'll have our little y-axis, which is going to represent our imaginary axes. And then we'll have the x-axis, that's going to represent the real part. So -1 in the real, that's going to go -1 to the right, and then up root 3. So let's go ahead and draw the angle that's associated with that point on the terminal side. And that'll be theta, and that's r. And there's a relationship between the -1 root 3 and r and theta. So we know that r is equal to the square root of x squared plus y squared, which is equal to the square root of -1 squared plus root 3 squared, which is equal to 1 plus 3, which is 4 or 2. But we also already know that because 1 root 3, 2 is a special triangle. That implies that you're going to have a 30-degree, 90-degree, 60-degree triangle, where 1 corresponds to the 30 degrees, 2 corresponds to the hypotenuse, will be opposite it, and root 3 will be opposite the 60-degree part of the triangle. So we already kind of knew that r would be 2 if this directed distance is 1 and this is root 3. So I'll go ahead and drop a perpendicular from my point on the terminal side to the x-axis, and then I'll go ahead and draw my little right angle. Woohoo! So this will be root 3, and this distance here will be represented by 1. And the directed distance, we would put a -1. Well, it turns out 60 degrees is always going to be opposite the root 3. So I know that this angle that I'll label in red, I'll call it alpha. I know alpha is going to equal 60 degrees because it's always opposite root 3. So if I know alpha is equal to 60 degrees, I can find theta, because I know for the reference angle, we know that theta is always going to equal 180 degrees minus the reference angle alpha. Well, now we have it in reverse. We have alpha, which is the 60 degrees. So we have theta is equal to 180 degrees minus 60 degrees. Actually, I said that backwards. We know that the reference angle is 180 minus theta. Yeah, I wrote that backwards. Let me write that the right way. And it turns out they're equivalent. Alpha equal 180 minus theta. If you add theta and subtract alpha, you'll get the same thing. Alrighty, so that's what we did. We subtracted alpha, which is the 60 degrees, and 180 minus 60 is going to give us 120 degrees. So that way we know theta is 120. So once you know r and theta, then you can find the square root. So we have x squared equaling -1 plus root 3i is the same as x squared equaling 4, because that was r. Excuse me, r wasn't 4, it was 2. Oh, what's going on with this thing? It keeps moving. So we're going to have 2 cis 120 degrees. In order to take the square root by de Moivre's theorem, we would take the square root of the r value. So x is going to equal the square root of 2 cis, and then we're going to take 120 degrees. We're going to add 360 degrees, and it's divide by 2. And how many 360s do we add? Well, it's a multiple of k, where k is going to equal 0 to 1. And you say, well, how do you know that it's going to stop at 1? Well, it turns out it's going to stop at 1 because it's always going to be 1 less than the exponent of 2. So if you were taking the cube root, it would go 0, 1, 2. 1 less than 3 is 2. If it were the fourth root, it would go 0, 1, 2, 3, because 1 less than 4 is 3. All right, so that's going to give us our 2 roots. And then if we simplify, we get root 2 cis 60 degrees plus 180 degrees times k, where k is going to equal 0 and 1. So let's take a look at when k is 0. So k equal to 0, we get the square root of 2 cis 60 degrees, because 180 times 0 is just 0, so we don't have that 180, so we'll get rid of that. And then when k is equal to 1, we get root 2 cis 60 degrees plus 180 degrees times 1, which is just the same as 180. And when you add 60 and 180, then that gives you root 2 cis 240. Now you could stop here, but they want you to write the values in rectangular form. And so we need to go ahead and do that in the next step. So let's do root 260 and root 2 cis 240. So we have root 2 cis 60. That's shorthand for root 2 times the cosine of 60 degrees plus I sine 60 degrees. And we know that the cosine of 60 degrees is 1/2, and the sine of 60 degrees is root 3 over 2. So we have root 2 over 2 plus I times root 6 over 2, and I multiplied root 2 times root 3 to give me root 6. Let's do root 2 cis 240. So root 2 cis 240 is equal to root 2 cosine of 240 plus I sine of 240 degrees. And that's going to give me root 2. And 240 is going to be in the third quadrant. It's going to have a reference angle of 60 degrees. And so we know that the cosine is going to be negative, so we're going to get a negative 1/2. And then we also know that the sine is negative, so we're going to have minus root 3. So we're going to have minus 1/2 plus I sine minus, sorry, not I sine. The sine of 240 is minus root 3 over 2. So we're going to have the same answer that we had up above, except for both the terms will be negative. So we have minus root 2 over 2 minus I times root 6 over 2. And I believe on Alex, they'll write the I after the number. So let me go ahead and write the I second. After checking the answer on Alex, it turns out they took it even though I wrote the I first. So whether you write it first or second, it's okay.